Hello everyone, my name is Hugo Dorado. I'm a Biodiversity Sea Alliance researcher, and today's presentation is called Case Studies, Examples of Data Science Application in Agriculture. This material is part of the foundation module for information analysis and data mining in agriculture done between the CED Biodiversity Alliance, Illinois, CIMMYT, and the CCAPS project. In this presentation, I'd like to share with you three examples of projects that we have developed where we've used data science as a tool for decision-making process. I hope that you can have a more clear idea of the potential of using data doing research in agriculture after going through this presentation. The first case study was developed in Plantain in Colombia. This time we worked jointly with Frucol. In order to record information from producers, we had to have access to primary information. We had to establish information collection process in the field because plantain isn't a researched crop. So we used the Cropster platform that's developed to capture and store information from with information like geographical position, yield, harvest day, sowing date, and other variables. To complement this management information with climate and soil information, we used the secondary information. In that case, we used the World Claim database. This is a source of data that's free and has 1 kilometer of resolution, and began in 1950 and it was extended to 2000. This free information can be downloaded and it can be integrated to the crops by using the georeference coordinates. In order to capture the information of soil, especially the physical properties, we use the Rasta method. This allows to do a simple characterization, and some producers can even do it by themselves, where a list of steps are followed to identify what are the textures, what's the structure, what's the color, and some characteristics of the soil that will afterwards allow us to link this information to the analysis that we are performing. The objective in this project was to identify the potential of varieties in different zones in Colombia. But as you can see in the map, each one of the red dots, it's a plot of a producer. So we had a great diversity of contexts and types of soil. Right here we have the mountain range, so there were producers that were in productive systems that were different. They had different biophysical conditions. Therefore, we had a lot of variability in terms of the data that we collected. In this project, we were able to collect approximately 100 productive lots. The application was to provide information to the growers on cultivars with a higher potential according to their specific site conditions. In this map, we can see the first result. Our strategy first was to identify which producers had the same climate conditions and soil conditions. This would allow us to compare this information afterwards, collect information of the producers, and identify which were the ones that were doing the best practices in terms of management, determined by the system where they were located in. We can identify that each color represents a specific zone. So the producers that would be included in the blue zone are going to have the same conditions. An interesting finding that we identified is that despite the fact that some producers are spatially distant, as you can see with the blue spots, they might share the same climatic and soil conditions, or at least similar conditions. So the technology that's effective in one of these sites can be shared between them in order to improve their productive system. To determine the zones, we use one of the data mining processes that's called cluster analysis. This allows us to identify between a group of observations to determine which are the most similar among them in order to create different groups. This analysis is very useful when we have a lot of variability in the data. We try to do a segmentation of this information. We'll also analyze the distribution of the yield. Some growers had just one crop and others have associated crops. And we identify that despite that there are producers that have the same environmental conditions regarding the climate and the soil, there's a lot of variability in the yield. It would suggest that some producers are using the proper practices and they can be looking in the upper part, but others still have the potential to increase their yield. So that's where we want to concentrate our efforts to try and identify what was being done by these producers that were being successful that could be used by those that aren't so successful, that are in the lower part of the plot for yield. In order to explore to explore these groups that we generated, we used the mixed models to try and identify what was the factor that predominated the zone, what was the variety that had the best yield in the zone, and the behavior was the same in all the zones. The first thing that we identified in terms of yield is that some zones definitely have a higher productive potential than others. We can see the second zone in this part, that it has a higher average yield compared to the third one that you see in the graph, where most of them are below the average. Most of the producers, they might be below the average. This does not mean that the crop is not profitable, because there are other factors that intervene in the decision taken by the producer in the end. But beforehand, we understand that the potential of the yield is not so high compared to others. The mixed models also helped us to identify what was the most efficient variety in each one of the zones. For example, in the first zone, as you can see in the graph, there's a variety called Dominico that has a higher potential in terms of yield. And the same thing that the fourth zone, while the people that mixed different varieties have a yield that's below the average. The second zone, as you can see, is that regardless of the variety that they plant, there's not too much difference in terms of the yield that can be generated, that can be expected. So this analysis allowed us to identify those varieties that have the most potential, which was assessed with the producers afterwards in order to motivate the decisions that they could take in the future if they decide to move to a variety that has more potential for yield, or to maintain the ones that they're using. They probably have other economical factors that are good for him. The second case was focused on rice in Colombia. In this case, we work with the Ministry of Agriculture in Colombia, CIED as the research center, and the Fondo Nacional de Arroz, the Rice Federation in Colombia. It's an association of rice producers in Colombia, and they carry out a lot of research in this crop. And this case has a special characteristic because there was a lot of secondary information available. They collected information from several years through different means, different strategies they had for collecting information. Among them, there was a national survey for rice that was performed every 2 years, and the technicians had records for harvest, the sowing and harvest, the dates, varieties, yield. And fortunately, this year, in approximately 2015, they opened the data for climate information in Colombia. So we had access to some of the stations that were nearby to the rice sites, which was a great advantage in order to have access to that information. So from out of all the information that we were able to collect, we had approximately 7,837 observations, like the sites of the harvest, the site of the meteorological stations. So this was a treasure of the information for this project. So we concentrated on analyzing 2 sites, one in Tolima and the other one in Meta. And the objective was to assess the effect of climates and some cultivars of rice in two locations in Colombia. So since the main interest was focused on assessing the climate effect, we didn't give too much priority to the different varieties, just the soil varieties. We concentrated the production systems. There are two of them. One is on secano, and the other one with irrigation, dry and irrigation. So we were trying to determine the optimal dates for sowing and to know the different conditions of the cultivars based on the climatic conditions. The observation unit was defined as you can see in this slide. We were interested in everything that could happen from the moment when the producer was sowing until he harvested. And that productive cycle was divided in three phases based on the what the experts told us, according to what we wanted to do. So we had a vegetative phase, reproductive, and feeling. The variables that were involved were the date of sowing, the harvest date, the variety. We specifically worked with four varieties. We defined two locations, Saldaña and Villavicencio. And the climate variables that we assessed were average temperature, accumulated solar energy, accumulated precipitation, number of days with rainfall, and average relative humidity, and the yield, which was our response variable. We used the random forest methodology that we're going to see also afterwards in the course, because this one had a special characteristic, and it's that it gave us the best performance in the quality of the predictions. It had non-linear predictions, and this it was very hard to maintain the linearity in this study, and it was also to balance the influence by correlation between variables. And this is one of the disadvantages some methodologies have. In this case, the climate variables were correlated with the temperature could be associated to rainfall or to the relative humidity. So this was a very flexible methodology to identify all these. So the first thing that we identified with the methodologies, what was the most relevant factor for each one of the varieties in each one of the zones. So we were interested in identifying what was that variety that was most sensitive and in which moment of the productive cycle it was sensitive. And we also wanted to identify what percentage of the variation could be explained just by the weather, according to the site and the variety that was used. So here we can see the results. First of all, we identified that there are varieties like the F16 Saldaña that appears to be more sensitive to the climate. As you can see, the performance was at 46.60%, just with the variables that were explained by the climate, while other variables like Lagunas only had a performance of 6.96%, and they had the same variables that were included in the analysis. So this suggests that there are some varieties that can be a lot more sensitive to the climate conditions. The most relevant variables that we identified for each zone was accumulated solar energy in the last phase of the crop, the average temperature in the reproductive stage, and Lagunas had the average temperature and also in the grain filling phase, and the dry system was affected by the days of rainfall. Now we could think that these performances are very low. In this case, we were not interested in a predictive model. We were interested mostly on explaining or understanding how that set of variables from the climate affected the final yield. So we didn't use a prediction model in this case. This random forest model also has the advantage that allows us to assess uh, how much the variables depend on the input and the output variables. So we can see that the distribution of precipitation or rainfall for the F174 variety in Villavicencio should have at least 40% of days with rainfall in the vegetative stage in order to achieve the best yield. And the same thing for the F733 variety in Saldaña. The idea would be to have 21,000 calories per square centimeter in the end of the cycle, in the vegetative stage. So the usefulness of this information, on one side, the producers could determine the plantation dates in the year in order to accommodate themselves to the best conditions, so that if they're going to plant an F733 variety, they should take advantage of the days when they sow, so that in the last month coincides with the days with the high solar radiation to obtain the best possible yield. On the other hand, for the improvers, this can also be useful because it would allow them to test the resistance of climate factors to certain varieties that are developed based on the data that was explored by the producers, that were generated by the producers. So you can also get a hypothesis for those improvers. And the last case is a research that we've done with CIMIT, with the participation with CONAGUA, the National Meteorological Organization in Mexico, and INIFAP, the National Institute for um, Research in Agriculture. The information that we used came basically from the Masagro records. Um, there were more than 8 years of research with a total estimate of 4,500 observations and harvest cycles in the state of Chiapas. The target was maize and corn that was planted in a dry system. The objective of this project was to identify the to see what were the factors that affect the yield of corn. And the application with this project was to provide site-specific information to producers to improve the yields. And different to the two last projects where the information for management was scarce or lacking, in this case, a lot of information was acquired for monitoring, for fertilization, plague control, disease control, and some additional information. And once again, we chose random forest because of the flexibility that this method offers to to assess the relations that exist between the databases where the linearity supposition doesn't necessarily exist. And random forest allowed us to identify that the variety and the rate of seed and the nitrogen are the most relevant variables that affect the yields in corn in Chiapas. This model explains 73.8% of the variation. This is one of the highest numbers that we have achieved with this type of data. Remember that this information is observational information from the producers, not experimental data. So a performance that's above 70% can be seen as quite interesting. We also use this method with random forest to generate the partial dependencies. In this case, we were able to identify that in the most efficient practices that have the potential to lead to a higher yield was to use 60,000 seeds per hectare as the sowing density, to have an optimum amount of nitrogen of 180 kilograms per hectare, and that using more doesn't necessarily improve the yield. We also identified that the daytime range, that's the difference between the minimum and maximum temperature, was ideal to be below 11.5 Celsius degrees. And like all dry systems, it required at least 30% of days with rain, 30% in order to guarantee the best yield. We also evaluated the relationship between the varieties, and we found that some material, hybrid material like the P4063W and RW4000, have a high yield potential. And there are some Creole varieties that also have a good yield. They don't reach the hybrids, but compared to other Creole varieties, they still have a good performance. We also use the predictive model capacity in the model to combine it with the climate forecast. And to do this, we established in a meteorological station, a range of 10 kilometers around a radius, and we identified the lots that were close to that coverage area for this climate forecast. And the idea was to identify which practices could optimize the yield based on that climate forecast. In total, we covered 93 harvest cycles where different varieties were planted. The objective with this exercise was to identify, based on this climate forecast, which were the best practices that the producers should combine in order to use their full potential. This is the example of one producer that the ideal situation was to plant with a rate of 55,000 seeds per hectare and choose the variety called P4082W. The optimum amount of nitrogen was in 125 tons per hectare approximately. I hope that these examples were able to enlighten you about the idea of using data science for decision making in agriculture, and that you are able to generate some ideas on how that tool can be applied in the research that you are performing. With this, we close the first introduction module, and I hope that you can take advantage of this course from now on. And thank you very much for watching this video.